Okay, so find the values of x where the function f of x equals 2x cubed minus 9x squared plus 12x as a local maximum or minimum. So colleagues, step one, what do we do? Already. We have forgot. Madam, you have been quiet. What do we do step one? Madam Florence, you've been quiet. I've only heard four people today, if I'm not mistaken. That was Mr. Emmanuel, Madam Sylvia, Mr. Vincent, and I think Mr. Sid. Have I missed out anyone? So that's wrong idea. Okay. But I believe Madam Sylvia. Okay. Mr. Foster, you've been quiet. What's the first step? Okay. Okay. So when it's brought like this, f of x to show the differentiation, you can put it like this. Okay. F. Yes. All right. When you see this one line, it means the first differentiation. Okay. When you see two lines, second. If you see three lines, third differentiation. Okay. Aha. So let's derive. What do we get? Yes, sir. Yes, sir. Please. Yes. 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 Mm-hmm. Yes. So you're going to write 6x squared. Mhm. Let me just bring it close here. So 6x squared. Yeah. Mm-hmm. Equals. Mm-hmm. Mm-hmm. You can simplify this. Oh, I forget. Yes. Okay, just hold on. Mm. But once you are used with quadratic equations, you don't need to write your A, B, and C. Okay, you already know. Okay, A times C is 2. Okay, so factors of 2 that when you multiply them, they should give you this positive 2. And when you add them, they should give you negative 3. So what are those two factors? Yes. Okay, we are moving. Yes, this is how it should be. Mhm. Let's write the full expression first. Mhm. Mhm. The common factor between x squared minus. Yes. Or in a simple way, you can say x squared divided by x. That's how you get x. X divided by x, that is 1. Mm. Or your negative x divided by x gives you negative 1. Then, mhm. You can do it like this. Okay, you can just negative 2. So you say negative 2x divided by negative 2x. 2 divided by negative 2. Uh-huh. Mhm. 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 Yes, we get the second derivative. We can, since we've used this one here, you can also use this one here. Mhm. Okay. So we do the second derivative, you put it like this, 2 commas x. So this, we're trying to derive this one, x squared minus 3x plus 2. Oh, Mr. Foster, let's just hold on. Colleagues, any questions along the way? Any questions? Some are dosing. Some are dosing. Mm. Mm. Okay, okay, okay. Mr. Foster, you're doing a wonderful job. I'm impressed. I'm happy. Flawless. This is flawless. Mm. So when we do that, we, are we to, I believe we're together. Mhm. Second derivative is it's less than zero maximum. You because remember, for a quadratic equation, okay, for a quadratic equation, if your first coefficient is less than zero, it means your quadratic equation looks like that's what what's up. Yes. If your quadratic equation, your coefficient is greater than zero, first let's start with greater than zero. If your coefficient is greater than zero, your quadratic equation will look like this. Okay. And this is your minimum point. And if your coefficient is less than zero, your quadratic equation is like this. And this is your maximum point. So this is the logic that is being used here. So if your second derivative is less than zero, maximum. If your second derivative is greater than zero, what is it, Mr. Foster? Minimum. So we substitute. We start with x equals 1. Let's substitute. Mhm. Negative 1 is less than 0, right? So x equals 1 is our. Then, yes, Mr. Foster. Mhm. Since 1 is greater than 0, Yes, X equals 2 is the minimum. Yes. Thank you, Mr. Foster. That was flawless. No need for, there was no need for me to correct you. Yes. I believe